Hi, my name is Mike Callahan. I'm a STEM educator, and welcome to Programming on Purpose with Python. This will be the first in a series of slides where we will develop a GUI discount calculator. Using Python, we're going to design a discount calculator, which will be able to run on any platform with Python installed. Along the way, we're going to learn about Python objects, variables, and functions. We're also going to learn how to work with Python in the shell and the editor. Now, I know I'm asking a lot out of an hour or so, but we're only going to concentrate on the parts of the language that we need for this particular task. That's going to get us started in the right direction, and at the end, we'll discuss further educational options. Now, most of the time when you learn a new computer programming language, you learn a little piece of the language, and then you're given examples on how you can explore how these pieces operate. But here we're going to turn things around a little bit. We're going to be focused on developing a single application. And as we need them, we're going to introduce the parts of Python that we'll need to accomplish our task. So the application development and the learning of Python will occur at the same time. Now, normally, you don't get into GUI interfaces when you're first starting to learn how to use a programming language. But because we're going to need it pretty quickly, we're going to get into graphical user interface design a lot earlier than you would expect. Now, this actually is going to make programming more fun, and you'll see why a little bit later. Unlike most of the things you find on YouTube, you might be asking yourself, hey, where's the video? Well, the purpose of these slideshows is to teach programming. And the code is the most important thing. So rather than show a video of me typing in front of a computer screen, I think it's much better to use a narrated slideshow that is easy to freeze and for you to copy the code into your editor. So that's why you're not going to see me. In order to go through these slides, you're going to have to install some software on your machine. First, you need Python 3, the latest version. So just go to www.python.org and download that and install it for your particular platform. Now, you should also get something called idle and the tk-enter library. So we're going to check to make sure that that happened. After you install Python, go to your Start menu and bring up idle. It should be under the Python group. And then you'll see something that pops up, which we will call the shell window. And there's little 3 greater than signs. That's called a prompt. In that prompt, I want you to type the word import and then a space and the word tk-enter and then hit enter. Hopefully, you will see another prompt pop up right underneath it, and that means you're good to go. If you start seeing error messages, then you're going to have to go online and read how to fix tk-enter. So let's assume that tk-enter is there. So now you have to download and install a library that I wrote called tk-enter toy. For Windows people, you have to right-click on the Start window and select Windows PowerShell Admin. For you other platforms, just get to the command line. In either case, for the Windows people, type in py-m, then pip install, and then tkintertoy, tk-enter toy, and hit enter. You should see a lot of things happen, but hopefully at the very bottom it'll say TK Enter Toy was installed. If you get error messages saying that you don't have the right permissions to do this, then try another line, py space -m space pip space install space -user space TK Enter Toy. And this will do the same thing, except it will just install it just in the user directory. If both of these fail, then you're going to have to go online and read how to fix pip. You won't be able to do anything on the later set of slides unless TK Enter Toy is installed. By the way, pip uses a website called pypi.org, pypi.org, and that's where you get the libraries. Now, Tinkertoy should work anywhere Python 3 and TK Enter are installed, and it has been tested on Windows and Linux. You can also install Python 3 on Android devices. So all you have to do is go to the Play Store and look for PyDroid 3 from IIEC. Now this package is complete. It also includes TK Enter and pip. So to get Tinkertoy on your device, all you have to do is go to the menu, bring up pip, and just search for TKINTER toy, and then click on install, and it will take care of it for you. The editor that comes with PyDroid 3 is not idle, but it's actually a more advanced editor. Now, like most free Android apps, you will see ads anytime you run a file. So this can get pretty irritating. So in order to remove the ads and also to get a better system, it costs $10, and it's well worth it if you're going to do any work on Android. Now, I don't recommend typing code on a cell phone. It's pretty difficult. But if you have a tablet, this might be a good way of learning how to do programming. There might be other Pythons for Android, but this is the only one I could find that works with Tinkertoy. Let's cover some conventions that will be used in these slides. Code will be in a monospaced text. It will look like typewriter text. And any new code that is on the screen will be highlighted in yellow. Something called objects will be in a bold, rounded text, and any new words that we introduce will be in italics. So we're going to start with an introduction to the Python shell and the idle editor. Then we're going to define the tasks we need. We're going to develop the code to accomplish that task. And finally, we'll organize our code into functions. Our first task is pretty straightforward. We're going to design a calculator that can handle sales and coupons. This is commonly called a double play by the shoppers. Now, what does a double discount calculator need to do? Well, it has to handle sales and coupons, and you just can't simply add discounts together. Turns out it's a little more complicated. So we want our function to return the final price and the total discount, which it will include the sales and any coupons we have. Let's tackle the math. It's pretty straightforward. So we'll start with this shirt that costs $39.95, and this week shirts are 30% off. So what's our price? Well, all you have to do is take $39.95 times 1 minus 30%, which will be 70%, and you end up with $27.97, which is our sale price. But with double discount, things get a little more complicated. The shirt costs $39.95, But this week, shirts are 30% off. And also, you have a coupon that allows you to take additional 15% off. Well, what's the final price? Well, first you take your first discount, which we've already calculated at $27.97. But now you take the 15% off of the $27.97, and doing the math, you come up with $23.77. Now notice that your total discount is not 45%. It's actually 40.5%. And the reason for that is because you are discounting an already discounted price, so you're not going to get the full 45% discount. Now, one of the advantages Python has on other programming languages, Python is truly an interactive, interpreted language. And what that means is basically you can type anything on what's called a prompt, and Python will do it right before your very eyes. And I believe that really there is no better way to learn about a programming language than an interactive, interpreted language. So we're going to first bring up Python. I don't know exactly what platform you're working with, but hopefully you have Python 3.7 or later installed. And I want you to bring up the thing that's called idle. Idle is what we call a development platform, and it's included in almost every Python installation. So hopefully you have idle on your system. Now it's pretty primitive, and it basically contains something called a shell and an editor. Now, certainly idle is not the best development system available, but I think for beginners, it's going to work for our purpose. And there are better systems out there, but sometimes for a beginner, the more useful systems might be a little too complex. So I believe idle is a good first step. And like I said, no matter what platform you're dealing with, hopefully idle will be there. Everything in Python is called an object. An object is basically a section of memory that's devoted to something. Some objects can have labels, which we're going to call variables. In Python, variables must start with either a letter or an underscore. Variables that start with underscores are special, and we're not going to get into them here. But the one thing you have to remember, case is important. So if you have a variable that is in uppercase and another variable that has the same letters that's in lowercase, that's actually two different variables. Here's a graphical representation of what I was trying to say is you have a chunk of memory, and that holds some sort of object. And the object can be just about anything you can imagine. And then you have a variable which you assign that will label that object so you can get to it. So we have our variables. The initial price we're going to call initial. There's no sense in being too clever when you're programming. Just basically label everything what it is. I'm a little bit lazy on typing, and so my variable names have a tendency to be fairly short, but I try to use complete words. The sale percentage, we're just going to call sale. The discounted price, we're going to call discount. The coupon percentage, we're going to call coupon. The final price will be final. And the total percentage savings, we're just going to call total. This is how you actually get information into a variable. It's called binding or assignment. And almost every computer language uses this type of syntax. The name of the variable, an equal sign, and then some sort of object expression. And usually you want to have spaces between everything. It just makes it look nicer. Now, the one thing I want to point out is the equals is not an equals in the term of like you would see in a mathematical equation. The best way to think of it is that you are putting something into the variable. So maybe think of a left pointing arrow. The expression can be very simple, can be complex, or anything that you can imagine. Nice thing about Python is you do not have to declare the variable. Python will actually look at the object expression and change the type of variable to whatever that object is. So here is a little diagram. It basically shows you our variables and what they're going to hold. You can see initial, sale, and coupon will all hold information that the user inputs. And then discount, final, and total will all hold information that the program calculates. Now, it's time to talk about the different types of numbers that are in Python. Python actually can deal with lots of different types of numbers, but we're only going to look at two here. One are integers, and basically numbers with no decimal points. The way Python was designed is there's no limit. Basically, it's limited to how much memory you have on your computer. Integer calculations are also very precise. No rounding problems. Float is, you'll see a decimal point and perhaps an optional power of 10. The nice thing about floating numbers is you don't have to keep track of the decimal point. It does it for you automatically. The bad thing about them is floating numbers are not precise. It is impossible to represent every base 10 floating number in binary, and that's where the problem comes out. For most of the time, it's not going to be important for our purposes. If we were actually writing programs that were calculating money and we had to be exact to the nearest penny, we would have to use another type of number that's built into Python. But we're not going to get into that right now. For our purposes, if we're off a penny or two, it's no big deal. So we're just going to go with floating point numbers. Now we're going to look at what I call containers. There's two types of basic containers in Python. The first type is what we call a sequence. And this is data that is referenced by an index number, a number between 0 and some other number. We're going to look at three different types in our programs here. The first one, most common one, is called a string. And that's basically a sequence of alphanumeric characters that are stuck together. Strings cannot be changed, so we call that immutable. But this is not as big a problem as you might think, because it's very easy to create a new string from an existing string. An example of a string is my name with a capital M-I-K-E, all stuck together. Of course, if we just had to limit ourselves to characters, it wouldn't be very useful. So Python also allows things called lists. And lists are just basically a sequence of objects that we can change. And the objects don't have to be the same. So you can mix strings and numbers and anything you can think of and stick it all together. And so here I have an example of a character or a string, one character string, a letter A, an integer, and a floating point number, all organized together. The other type in Python is called a tuple, and the only difference between a tuple and a list is you can't change a tuple. A tuple is what's called immutable, so that means once you create the tuple, you can't change it. And there are lots of examples where that is useful, and we'll see that a little bit later on. The only difference between a list and a tuple in Python as far as creating it and the syntax is lists have square brackets, tuples have parentheses. Okay, we're going to be doing a lot with strings, so let's take a closer look. Strings are a very important part of almost all computer languages. And in Python, like most of the other programming languages, strings are surrounded, and the correct word is delimited, by single or double quotes. Now, if you look at your keyboard, most of the time you will see that the single quote is an unshifted key. So most programmers use single quotes. However, there are some languages that require double quotes, and they just don't like to shift. Programmers who are used to typing in double quotes will use double quotes. Python, you can go either way. You must be consistent, however, so if you start with a single quote, you must end with a single quote. And the reason why Python allows both is because it is possible to have strings that have quotes. So in the examples we have below here, you can see I went with Mike either with single or double quotes. But if I want to say something like Mike's laptop, which has a single quote in the middle of the string, then you must use double quotes. And vice versa, if you have a double quote in the middle of the string, you must use single quotes. A very common mistake when you start programming is forgetting to put the delimiter around the strings. So here's an example of I'm trying to assign a variable first underscore name equal to Mike, and I forgot my delimiter. Now Python isn't going to say, oh, you forgot a delimiter. What Python is going to assume is that Mike is another variable pointing to an object. And so the error message you get is Mike is not defined. So of course the fix for it is simply including the delimiters around the strings. Python includes something called an index operator for extracting an element in a sequence. So here we have a string, and the index operator looks like square brackets. So whatever's in between the square brackets, that's going to be your index. You count from 0, and if the index is negative, then you count from the back. That's a very nice, useful feature. If the index is too large, then that will cause an error. So we have an example. We have a string, A, B, C, D, E, F, G. We're assigning that to something called SEQ, short for sequence. So I apply the 0th index operator to SEQ, and I get an A, which is, of course, the first character in the string. If you apply the index operator of 1, then you'll return B, the second character. And if you return the -1 as the index operator, then that will return the last character, which is G. And -2 will be the second to the last character, which is F. So here is an example. If you do 10, well, there's not 10 characters in that string, and so that is going to return an error. The other type of container in Python is mapped. And the most common type of mapped container in Python is something called a dictionary. Mapped containers are not referenced by index values. They're referenced by something called a key. The key is an immutable object, usually a string, but here you can see that a tuple might be useful. The syntax for creating a dictionary looks like this. You have a object a variable equals, and then you start with a curlicue bracket, the first item in your dictionary, which consists of the key, a colon, and a value. So I've created a little dictionary here of ages. So we know that Jimmy is 34. To get to the next item in the dictionary, you use a comma. So we have Billy with an age of 32, comma, and then Sue with an age of 36. And be sure you end it with that ending curlicue bracket. The way you access information in a dictionary is you just list the name of the dictionary, ages, and then it looks like an index operator, but instead of a number in there, it is the string, the key. So ages, Jimmy is 34, ages of Billy, 32, ages of Sue is 36. Down below, you can see how this is structured inside the computer. You have an object with ages pointing to it. The object contains the three keys, Jimmy, Billy, and Sue, and they are connected to the values 34, 32, 36. Interesting thing about dictionaries is the order is undefined. The programmer does not need to worry about it. The computer takes care of that detail for you. So let's review the differences between sequenced and mapped. Sequenced are referenced by an index number, and the order is fixed. Mapped are referenced by a key, and the actual order is undefined. This means the programmer does not need to worry about that order. There are mapped structures in Python where the order is defined, but in our case, the dictionary is going to be good for what we need. Now we're going to look at the syntax of doing computer math. First, remember the two different types of numbers, floating point numbers and integers. We're going to be working in floating point numbers, so it's important to make all constants floating point as well. It's not a big problem, but there could be some rounding errors when you switch between integers and floating points. The other thing is the multiplication in almost every computer language is an asterisk. Reason why it's not an X, because X is a common variable name. So everyone pretty much decided to go with asterisks. Division is a / because the standard division symbol, you won't find it on a keyboard. The order of operations is the same you learned in school, but I like to use parentheses to eliminate any possible ambiguities. Of course, to convert from percentages to decimal fractions and going the other way, you have to multiply and divide by 100, and you'll see that decimal point in the 100 because these are floating point calculations. Also, we're going to have to round to the nearest cents for prices and the nearest tenth for total percentage discount. But there's a special thing in Python that makes that easy. Now let's convert our math to Python code. So we're assigning our variables, initial, sale, and coupon. Notice all the constants are floating point values. Then we calculate our discount, calculate final, and then finally calculate total using the exact same equations that we developed earlier. So here's an example of working in the shell. We are initializing our variables, initial to $39.95, sell to 30. And notice we're using floating point constants. We'll be doing it throughout these tests. And then we're writing the code for calculating discount. And you can see in the shell, if you just type the name of a variable, we'll get its current value. So then we throw in coupon, then we write the code for calculating final, and again we see the value there. And last, we write the code for calculating total, and we'll see the value here. Here's where you may want to freeze the screen and be sure you go through and type all this material to just kind of get used to working in the shell. It will be very useful later on. As nice as the shell is for doing work in Python, if we exit the program, we're going to lose all that work. So we need to move the code into an editor. In idle, that's very simple. All you have to do is say File and New File. And you can just copy and paste the lines from the shell into the editor, as you see we've done here. Notice I did delete the prompt because that would mess things up. It's also a good idea to put a comment header on the first line, basically identifying the file, what it does, when you wrote it, and who wrote it. This will help you out when you find files years later and you forgot what they did. Notice in the editor, if you want to see the results of a variable, you just can't put the variable name like we did in the shell. You actually have to use a print statement. So that's why that last line is print, and that's a function, final, comma, total. And function calls are done in parentheses. We'll discuss that in detail in a few slides later. Last, you want to save your file with File Save, and you want to save it under a name.py, and we picked Discalc. It's very important to do this routinely because idle does not have an autosave feature. So if you were working on this and you never saved it and you had a power glitch, you would lose all your work. So once we've saved our file, it's time to test it. And back in the Edit window, you click on Run Module. And you should see the values of your test show up in the shell window. Now we're going to talk about functions. Functions are a special type of code that will take an object and either change the object or create new objects. And the best way to think of them is kind of like a black box. An object goes into it and something different comes out. Now Python will include many functions that are already built in, but then we're also going to be adding functions. And you can bring in functions that are in collections called libraries. And this is the way you need to think about programming. There's no need to recreate the wheel. If someone has already written the code you need, all you need to do is just access it. To use a function, we commonly call that calling a function. And so you want to have the name of the function followed by parentheses and the objects that that particular function needs. And you don't want to have a space between the name of the function and those parentheses. You can have a space between the objects inside the parentheses. This is all good style. Now, the objects that are used when you call the function are called arguments. These arguments will replace objects when the function was created called parameters, and we'll see how this works a little bit later on. Now the function will commonly return a new object, and we're going to be sticking that into a new variable. Now if this variable is already assigned the old object will be destroyed and replaced by a new object. One of the great things about Python is you don't have to worry about this. That space will automatically be reclaimed, which that is commonly called garbage collected, and you won't run out of space. That was a big problem in C programs. But Python, you don't have to worry about things that are called memory leaks. That won't happen. So we're going to take that math that we typed in, and we're going to put it into our own function. This is the syntax that Python uses for creating your own function. You start out with the word def for define, the name of the function, and then the parameters that you want your function to work with. Notice the arguments that when you call the function will replace these parameters. They don't have to be the same word. Python will take care of that detail for you. Then this is the one thing you're probably going to forget. After the last parentheses, you have to have a colon at the end of that line. Then from this point on, everything must be indented. That's how Python organizes what are called blocks of code. It uses indentation. Everyone in the Python world uses 4 spaces, so you should also use 4 spaces. And then if your function returns something, then the very last statement has to be return. If you don't put that in there, then your function will run and return what's called a null object, and that might confuse you. So if you have to return something, be sure you put the word in there, return. You can see the little pound signs in there. Those are called comment lines, and that's not for the computer, that's for you and other programmers. You know, and this code, we're not going to do a lot of commenting because it's fairly easy, but when you start writing your own code, you want to make sure you use lots of comments. That'll help you out and also other programmers who are looking at your code. It's time to convert our file and create our own function. And the way you do this is those 3 lines where you initialize, just leave that alone. And let's put in a space. And then we're going to type a def line. The def line will be after the variables that got assigned. Then I'll show you exactly what that def line looks like. But the next 3 lines, they need to be indented. The easiest way to do that in the idle editor is just click on Format, Indent Region. And lastly, that print line is going to be turned into a return statement and also indented. So let's see what this looks like after we've made all these changes. So here we go. Here's our new file, DiskCalc. By the way, you might see 01 after DiskCalc. That is because I have to save the screens for making these shots. Just ignore that. Just store everything under DiskCalc.py. So here's our function call, def. We're going to call it double discount. I'm using that camel case where you actually capitalize the second word in the middle of the function name. Some people like that, some people don't. I like it, so that's where it is. And then you have your list of parameters that this function is going to use. We have initial, sale, coupon. Notice it is inside of parentheses separated by a comma. And then at the very end of that line, there is a colon. This is probably the #1 syntax error, is you'll forget that colon every now and then. It's very important. Python has to see it. Now notice all the lines underneath the def are indented. That is how Python knows where this function begins and ends. That's called a block of code. Underneath the function, we have a comment line, and this is the absolute minimum comment that you want to do for any function you write, basically tell it what it is. We will use more advanced methods later on. So there are those 3 lines of code. And then notice we turn the print into a return. But then we have a blank line, and then we have unindented the actual print statement we're going to use to test this function. And notice we are calling double discount with initial, sell, and coupon, and then the results of that we're going to print. So again, here's where you need to freeze your screen and make sure that your code looks like this. Now we need a function that rounds numbers. And fortunately, there's one built into Python called round, so we don't have to import anything. Now, round works a little bit differently from what you were taught by rounding to the nearest even number. So this is different from what you were taught in school, but there's a good reason for this, and it's what mathematicians prefer. To look at documentation on built-in functions, it's quite simple. In the shell window, click on Help and then Python Docs. Notice you can also press the F1 key to get there quickly. And you'll see a window pop up, and you want to look at the built-in functions, and you can see round is circled. Just click on it. Here's what the documentation looks like. And you can see, you can also get to the help from the shell. Anyway, you have that little section there about rounding is done to the nearest even choice. You can read about that. And again, this is something that some mathematicians prefer. And that's why Python implemented round in this method. There is a way of doing that from the command line inside of Python. If all you do is just type help, parens, and the name of the function that you want to look up. And then you should see the built-in information about the function. It's going to be not quite as extensive as what you see using the windowing version, but it can just maybe give you just enough of what you need. Also, you can test the function. So there's no better way to see how something works until you play with it. So here you can see a couple examples of I was using the rounding function, showing you how it doesn't quite work like you think it might. We are ready to include round into our function. So notice the only thing we are rounding is final and total. We're rounding final to 2 digits, and we're rounding total to 1 digit. So make these changes. Be sure you save your edits, and we should be good to go for our upcoming test. Now we are testing our function, and you can see you do that in the editor window under Run Module. I do want to add in, you have a check module, and that is good if you just want to check the syntax of what you've typed and don't actually want to execute anything. The syntax text is a little bit different because if you have no errors, nothing will happen. You would expect that you would get a message saying everything looks good, but that's not how idle works. If you do have an error, the error will show up in the shell window. Anyway, if you type run module, you can see that the results, again, will show up in the shell window. We've seen that running the module lets you test the code with your embedded test. However, if you import the module, as you see below, you can actually run other interactive tests. Now notice I used DiscCalc 1 instead of just plain old DiscCalc. And that's because I have to keep the functions separate for making my slides. So you would just import DiskCalc. Our function is complete and it works, but our application still has a long way to go. Users expect modern graphical user interface, not command line applications. So we're going to have to write a GUI. Now, writing GUIs can be complicated, but if you follow the installation instructions, you have a library that makes it easy to write simple GUIs. And we are going to tackle that task in the next slideshow. If you live in or near southern Indiana or Louisville, Kentucky, I teach 2-hour free seminars at both the Jeffersonville and the New Albany public libraries. If you're interested in attending these live training sessions, just call or go online to reserve your spot. Well, that's enough for one session. Thank you for listening. If you did enjoy this method of learning Python, be sure you just subscribe. And if you have some friends that want to learn how to do Python, be sure you tell them. And we'll see you at the next slideshow.